Our next separating technique is fractional distillation. This is very similar to simple distillation in that the mixture is heated and boiled and allowed to condense, and we collect the different fractions like that. It's a bit different though, because fractional distillation is used to separate, again not a chemical reaction, this is a separation technique, separate a mixture of liquids. Now if you remember simple distillation, that was used to get the solvent out of, say, salt and water, where one part of the mixture was salt, which is a solid at room temperature, but it's dissolved in the water. Now simple distillation works well for that, but with a mixture of liquids, if you just heat the mixture, then both the liquids have a habit of evaporating at the same time, and so you wouldn't separate it very well. So we need a little twist on simple distillation. An example of this is ethanol and water. Ethanol is the chemical name for alcohol. And water. Alcohol is a liquid, and so is water. Now this is how the whiskey industry works. They ferment up a weakly alcoholic solution of ethanol and water, and they concentrate it to make spirits like whiskey. So they distill the mixture to get the whiskey out. Now ethanol has a boiling point of about 78 degrees C, and water has a boiling point of 100 degrees C. Now if you just heat that mixture, they'll both evaporate together, so you don't get the separation. That's why simple distillation doesn't work. So we need fractional distillation used to separate a mixture of liquids. So the apparatus looks a lot very similar to simple distillation. This is the same, and this is the same. But what's different is this bit in the middle here. This is called a fractionating column. It's a much longer column here, and you can have many different designs. I've deliberately left that just as a very long glass tube, but when you see these things, I've often got more intricate glassware in the middle to increase the surface area to make this column longer. And basically down here we have our mixture, and our flask at the bottom here, and in our flask here is our mixture, say, of ethanol and water. Ethanol and water. Now if we say the ethanol is represented by a little solid black dot there, and the water maybe as a hollow pencil dot, in here we've got our water molecules, and I'm just going to do them quickly like that, and we've got our ethanol molecules like so. We've got this mixture. Now when we heat them, as I said, now if it rains outside, you get puddles of water. Now the water doesn't boil off the floor, it just evaporates. So this is what I'm trying to say, is that if you just allow liquids to evaporate, then everything will evaporate off, for example, like so. So when we start to heat it, we get molecules of water and molecules of ethanol evaporating off together. So if we went straight into the condenser, we would get no separation. Now, that's the purpose of this long fractionating column. So the ethanol has got a boiling point of 78 degrees C, and the water's got a boiling point of 100 degrees C. Now, the substance with the lower boiling point will climb up the column faster than the substance with the higher boiling points. The ethanol has a habit of making it, well, not has a habit, does make it all the way to the top. So I mean, the water molecule might get here and then might condense. It's cooled down enough to condense, and you'll see little drops of water appearing on the side of this fractionating column as they condense, and they drop back down and back into the flask. But the ethanol continues to make it to the top. Now when the ethanol molecules hit that thermometer at the top, the thermometer will read 78 degrees C, 78 degrees C, and we know we are collecting ethanol because we know the boiling point of ethanol is 78 degrees centigrade. The ethanol gas then comes into this condenser where it's cooled down because we've got cold water going in there. Remember, the cold water is a jacket, just surrounds this glass tube, and it acts as quite an effective cooling measure. So that's cold water. In the cold water, the cooling water comes out there and goes down the sink. And that provides a nice cool environment for these ethanol molecules to condense on the side of here and turn back to a liquid where they drop out of here, and we end up with ethanol in this beaker over here. This piece of apparatus was called a condenser. And that carries on, and we get quite a nice separation. We get about 96% pure ethanol over on this side from this fractional distillation apparatus. This was a flask, a round bottom flask. I'm just going to write flask there. Now you may say, well, how do we know, when all the ethanol's boiled off, surely water will start to boil over as well? And yes, it does. How do we know? How do we know? Because the thermometer here, instead of reading 78 degrees C, will start to rise, because when the boiling water hits it, water boils at 100, and that will start to rise up now. So we keep an eagle eye on this thermometer. When it starts to rise, we change this beaker over here, and we know we've got the pure ethanol off. So quickly explain how it works. Okay. It works because ethanol has a lower boiling point than water. The ethanol and water are boiled. The ethanol, because of its lower boiling point, reaches the top of the fractionating column first. The water will condense in the column and drop back into the flask. When I say the flask, I mean this flask at the bottom here. The ethanol is condensed in the condenser and collected in a separate beaker, and that's that beaker over there. So last question. How do you know when to change the beaker collecting the distillate? Answer, you watch the thermometer. We know we are collecting ethanol or alcohol when it reads 78 degrees C. When it starts rising, we change the beaker. And that is all we need to know about fractional distillation. Our next separating technique will be filtration. We'll do that in another video. That'll be quite a quick one because that's quite simple to understand after fractional distillation. I think fractional distillation is the hardest technique to understand.